problem 39 of Neetcode 150, remove node from n of linked list. So in this problem, we are given a linked list and also a value n. Alright. And basically here in the example 1, the value of n is 2. So if we start from the end of the list and we count 1, 2, alright, well, we get that value 3. And we basically have to return the linked list without that value 3. Clear enough? For example, here, on the example 2, if you have to remove the first value from the end of the linked list, well, you are going to remove 5, return an empty linked list. Okay. So how can we do this? Okay, so let's say that we have our linked list. So we have 1 that points to 2, which points to 3, which points to 4, which points to 5. And let's say that our n value is, let's say that it is 2, okay? So the goal here is basically gonna be to, it's gonna be to access that value here and to connect it, or basically cut these two links and create one big link here. And we have to do this in a time complexity of big O of n. All right. So one thing that we could basically do is to reverse the entire linked list and then remove that value at that end position, and then reverse once more the linked list. But this is a bit complicated, and we don't actually have to go through this entire process. So instead, let's just create a 2-pointer technique. Okay, so we have pointer 1 and you have pointer 2. Okay, and pointer 2 is going to start here at 1, and we want to make sure that the distance between the pointer 1 and the pointer 2 is actually the same, the distance of n here. All right, so our pointer 2, our pointer, or right pointer, is going to move to the right, so 1, 2 here. So our right pointer, let's just call this right, and L for left. And after this, they are going to move by 1 to the right, so both of them. Okay, can I just do this? Yep, there you go. Okay, so let me just rewrite that. All right, so we're going to do this, and every time they are basically going to move to the right until the right values becomes null. So here it is going to become none, because we do know that the last value of the linked list is actually pointing to none. All right. So we know that once the right pointer is actually at none, well, our left pointer is basically going to be one value to the left of that value we want to remove. So at this point, we can basically set that left pointer's value, that, well, if we call this left, for example, we can simply say that left.next is equal to left.next. So we are going to rewrite the next link to be equal to the next link. which is going to be 5. And this is what we are going to return. But notice that now, well, we have a right pointer that points to known, and we have a left one that points to a value that is somewhere in the list node. So we actually have to write, well, we have to um, to keep track, or like keep a pointer at the beginning of the linked list. So whatever you want to call it. Some people call it dummy. I can call it, let's say, just L LL for linked list. Okay, LL for linked list, and it's gonna be basically here, right? So it's gonna be pointing to the node list, the linked list. Sorry. So basically, no, let me just rewrite this because it is not super clear. Okay. And let's take another color. So you are gonna have, let's just write a circle here that is basically pointing to that node. And after this, you can take that pointer next. And this pointer next is basically going to be that entire linked list without the value at the position n starting from the, oh, okay, all right. All right. Okay, so I lost my connection. This is why we lost our values, but you got the concept. Now let's go ahead and actually solve this by first creating, let's just call this the linked, or like the new, just call this new list. Okay, and the new list is going to be equal to a list node, and we have to make sure that this list node is pointing at the head. And the first thing we have to do is basically give a placeholder value, whatever it is not important, and it's going to point to the head, so the first element of the linked list. Okay, and now we are going to create our left pointer that is initially going to point to that new list. And we're also going to create our right pointer, which basically going to be pointing to the start of the linked list, so the head. All right. And now we actually have to create that distance between our right pointer and our left. And how can we do this? Well, we can just hard code 2 because n might not always be 2. So we can simply say while n is greater than 0, we are going to move the right pointer, and we are going to decrement n by 1. So if I say while n is smaller than 0, and I say that right is equal to right left next. All right, and then I say n, and I decrement this n by 1. We are going to create our desired distance by doing this. And after this is where we actually want to keep moving both the left and the right pointer to the right by 1 until the right pointer points to known. So we are going to say while right, and while this conditions all, we are going to move our left by 1 up, and our right by 1. All right, cool. So after this condition breaks, we know that the left pointer is going to be pointing at the node before the node we want to remove. So we're going to basically set that that link. So next dot, or left dot next, it's going to be equal to left dot next dot next, and this is how we create a new link. Okay, and now we can return basically our new list dot next, because we're going to access the first element of that new list by doing so. So this should work, and there you go. This was problem 39 of Neetcode 150, remove node from n of a linked list. I hope you learned from this video, and I really hope to see you in the next one.